Hello everyone, I wanted to take this opportunity just to go over a couple more examples of interpreting pedigrees. So let's take a look at this chart in front of us that has 4 generations. Let's first count how many females there are affected. Remember, females are circles and affected would be colored in. So on this pedigree, I have 1, 2, 3, 4 females, all right, that are colored in. So you can see on the chart, I'm going to have 4 females that are fully colored in like that. And then for males colored in and affected, I have 1, 2, 3, 4, 5. All right, again, squares, and they are colored in. So I pretty much have a 1-to-1 ratio or a 50-50 ratio of males to females affected. So this pedigree is going to be autosomal. All right, so I'm not going to have to use X's or Y's. Is it dominant or recessive? Now, if I look at the majority of the pedigree, it looks dominant. All right, but for example, this individual down here, they're affected, but their parents are not. So the whole trait has to be recessive. That means anybody who is affected is fully recessive. I'm going to use little r's here. See how fast I can go through and do this. And everybody else who is not colored in, we know is at least dominant, but we don't necessarily know what their other trait or other allele is. We have to look at their offspring. So if I start with this individual here, the original father leading through to the multiple generations, he does have children with it, so he has to be a carrier for it. If I go down to this horizontal line, I have 3 individuals, 1, 2, 3, who are all normal, so they have at least one big R. Mom is going to give the recessive allele to all of them, so I do know for a fact that all of them are heterozygous. Now, if I go and continue down to this generation, so we have this parent here and this parent here who have been busy. They have 1, 2, 3, 4, 5, 6, 7, 8 children. Yikes. All right, but if we look at their children, again, everyone who's not affected is at least one big R. But we got to figure out what their other allele is. So they could all only have gotten the big R from mom. Dad can only give a little r, so all these children are in fact going to be heterozygous or carriers. Let's move over now to this half of the pedigree. So we have 2 individuals who also have quite a few children that are all unaffected. So big R, unaffected. All these children down here, unaffected. Dad, who is affected, is going to make all of these children heterozygous because he can only give a little r. Now, mom has had 1, 2, 3, 4, 5, 6, 7 children. So you could definitely make the argument that she is this genotype. However, this is not a sex-linked trait where I can make assumptions. If I was a betting man, I would probably bet she's this. But if I was a genetic counselor, I would still list her as a question mark until she got blood work done to actually confirm whether or not she is homozygous dominant or heterozygous carrier. So it's okay to use question marks. All right, let's go down and finish this with this generation down here. We figured out that the parents have to be heterozygous carriers. Now, for the 3 children who are not affected, that means they have to at least one big R. Let's pretend that this parent, the mom, gave them the dominant allele. So that leads us to, all right, well, which one did dad give? Did he give them a big R or a little r? You don't know. It's a flip of a coin, and they don't have any children to help us figure out if they do or don't. So all these kids down here will be question marks for their second allele. It's okay to use a question mark when there really truly is no way to possibly figure out what in fact they are. Here's another example. All right, so not as busy as the last one. I only have 2 males affected in this whole pedigree. So that tells me automatically this is an X-linked trait or a sex-linked trait. Each individual, this one and this one, have parents that are not affected, so this is an X-linked recessive trait. So that means that any male affected, I'm going to use R's again, is affected, so they have to be X little r y. Any male who's not affected, they're easy. X big R Y. With sex-linked traits, males are always easy to figure out. Again, it's the females who are more difficult. So every female here is normal. So I know every female is at least X big R. All right, we got to figure out what's on their second X. Now this female has a son over here who's affected. Females always give it to their children, so she has to be a carrier. If I go down to this daughter, she's normal, X big R, and dad would have had to have given her that one. So which one did mom give? Since we now know she's a carrier, did she give X big R or X little r? We have no idea. She doesn't have any children, so I can put her as a question mark. This daughter is normal, X big R from dad again, up top. Mom, we know is a carrier. Which one did she give? Well, she has 1, 2, 3 children, all females who are unaffected. That's not really helping us right now. We really need to see if she has at least one male affected to be a carrier, or 4 or more boys unaffected to say she's homozygous. I'm sorry, that say that she's homozygous dominant. So right now I'm going to put her as a question mark. And I'm going to proceed down. These 3 daughters are all normal. So dad has to make them normal. So he's going to give each of these daughters an X big R. Again, mom, we already don't know what she is technically at this point. So all of these daughters here are question marks for their second X. But the third daughter, right here, does have a son who's affected. So that makes her a carrier. Now, let's think this through. She's a carrier because she has a son who's affected. Well, who made her a carrier? Dad can only give the X big R, so guess what? This mom here, we now know, actually is a carrier. So see how they go down 2 generations to figure that out? These 2 still stay as question marks because they don't have any children yet, but sometimes it takes a little bit of, again, detective work over several generations to figure out what an individual is. And let's do one last one together here. So let's figure out, is it autosomal or sex-linked? I have 1, 2, 3, 4, 5, 6 females affected. And then I have just 1, 2, 3 males affected. So there's more females than males affected. That makes this an autosomal trait. Is it dominant or recessive? Well, every individual who's colored in, they're affected. Every individual here in this pedigree right now, if they're affected, they have at least one parent who's affected. So everyone down here has a parent affected. All 3 of these individuals have a parent affected. So it's a dominant trait. So this one gets really easy for a second. So since it's autosomal dominant, everyone here who's not colored in has to be homozygous recessive. So look at this. I don't know who any of these people are, but if I'm a genetic counselor, just by asking a couple questions, I'm figuring out genotypes of numerous individuals over several generations. So now my focus is only going to be now on, all right, what's the genotype of these people who are affected? We know it's an autosomal dominant trait. That means if they're colored in, they have at least one big R in this instance. So we got to figure out what's their second allele. Now this female right here, she's marrying into the family. I see she's giving it to all 3 of her children below, but that doesn't tell me what her second allele is. I would need to know what her mom and dad are. So even though I know she's affected, I'm still going to put a question mark on her second allele possibility. Yes, she has 3 kids affected. Yes, she could be X big R, or I'm sorry, big R, but I can't say that for sure. Now, all 3 of these children below, 1, 2, and 3, they're affected. They got it from mom. Dad up here is normal, so all 3 of them will be big X, keep wanting to say X, big R, little r. And then finally, down here again, all of these individuals down here are affected. We know they have 1 big R that makes them affected. That would have had to have come from mom here. Dad can only give a recessive R, so they're all heterozygous, even though they're still affected. I'm still going to say they are heterozygous. They're not carriers, all right? They're affected, all right? The only time you see a carrier is if this was a recessive trait. Well, in this instance, it's an autosomal dominant. So once again, follow the rules I outlined in the first lecture video on if it's an autosomal or sex-linked trait, or if it's a dominant or recessive trait, and then from there you can work out and determine what the genotypes are of most individuals over many generations. Thank you.